We are going to now finish off the examples from our learning intention of 2.8. So for this one, we've got the same thing where it's asking us to prove that the left-hand side is equal to the right-hand side. So the first thing I'm going to say is that my left-hand side is equal to log of 1 over 16. And of course, I'm making this equal to the right-hand side. So what I'm going to do first is I'm going to rewrite this using, again, our index law of a to the minus n is equal to 1 over a to the n. So this is going to become that log, and remember we imply that there is a base 10 here because there is nothing that has indicated what base this is. So then this is going to be 16 to the power of minus 1. And what I'm going to do is, remembering because of this minus 1 here, I can use my log law number 6. So I'm going to bring this minus 1 out the front so that this then tells me that minus the log base implied 10 is equal to 16. And I'm going to rewrite this so that this is, of course, to the power or something, to the power of something, just because, of course, this here's got a log of 2. So this is going to be minus log of 2 to the power of 4. And again, I'm going to use rule number 6 yet again to bring this 4 out the front. So this is going to be that minus 4 of log 2. And as you can see, I've shown that my left-hand side is equal to my right-hand side. The next thing we're going to do is look at if log 3 of a is equal to x and log 3 of b is equal to y, I need to express this term here in terms of x and y. So pretty much I need to kind of make this look like these two here so I can plug this into my expression. So the first thing I'm going to do is I'm actually going to separate this a squared and b using my log law of number 4. So we know that this is just going to be equal to, so I've got log of 3 a squared b. Separating this gives me log 3 of a squared plus log 3 of b. And now what I'm going to do is I'm going to bring out this 2 to the front using log law number 6 again. So this is going to be 2 of log 3a plus log 3 of b. Now you can see that once I've got that, this actually looks the same. Well, this part here, log a3 and log ab, it's exactly the same as this here. So I'm actually going to see wherever I see log 3 of a, I'm going to put x, and wherever I see log 3 of b, I'm going to put y. So this just becomes 2 of x plus y. Done. I've now written this expression in terms of my x and y. Let's move on to our next two examples. So both of these are asking me to simplify my expression and then find either x or k. So what I want to do is I want to try and get this so that I can cancel out these logs here so I can then solve for x. So the first thing I'm going to do is I'm actually going to use log law number 6, and I'm going to bring these back into my log here. So this is going to give me log of 10, and I've got x squared take 2x plus 8, and bringing this back in gives me log 10 of x to the power of 2. And the next thing I'm going to do is I said that I wanted to get rid of these log 10s here. So what I'm going to do is I'm going to have both of these as 10 to the power of this expression here. So if I rewrote this, this would be 10 to the power of log 10 of x squared take 2x plus 8. And this is going to be equal to 10 to the power of log 10 x squared. And now what I can do is cancel out this 10 and log base 10. So this leaves me with x squared take 2x plus 8 is equal to x squared. And now all I got to do is solve for x. So in this case here, I can see that, thank God it's not a quadratic, because this x squared on this side and this x squared on this side are actually both going to cancel each other out. So of course I'm running out of room here, so if we come up here, this is minus 2x plus 8 is equal to 0, and of course now we're just solving for x here. So there you go, my answer is that x is equal to 4. Now if I wanted to, I could verify my answer by plugging this into here to see if it actually equaled my left hand side. So if I did want to do that, I can see here that just by putting this 4 into this part here, these two technically would disappear and I'd just be left with log 10 of x squared equal to log 10 of x squared. So these two actually are equal to each other, so my answer definitely must be that x is equal to 4. Of course, you could just plug in the whole thing and see if both of these, of course, equal each other, but we can see that it would just by just putting it into this part. Now let's have a look at our very last example, and again it's asking us to simplify and find k. So for this first one, I am going to use log law 6 yet again, where I'm going to put this 2 back into this parentheses here. So rewriting this gives me log a of 11 over 3 plus log a of 490 over 297, take away log a of 7 squared, which is 49, over 9 squared, which is 81. And of course, this is all equal to log a of k. Now I can use my log law 4 and 5, so remembering that I can now multiply these two together, but then divide this part here. So this is going to be log a of 11 over 3 multiplied by 490 over 297, and I'm going to divide by 49 over 81, but of course I've got dividing by fractions, so if I flip these two around and change this into a times sign, I can put these all in terms of just multiplication, so I'm going to do that. So times by 81 over 49, and this is going to be equal to log a of k. Now, just as we've done in the previous question up here, I'm going to put all of this to the raise it a to the power of this. So I'm going to have a to the power of log a of 11 over 3 times by 490 over 297 times by 81 over 49 equal to a to the power of log a of k. Now we can cancel these out, and I'm just going to be left with this number yet again, which if I actually plug this into my calculator, you'll actually find that this is actually quite a nice number. So it's actually 10, and that's actually equal to k. So there we go, that's my final answer. So therefore k is equal to 10. And now we've done all the examples for 2.8.